Hello, welcome back. In this video, we're going to be talking about 4.6. So make sure you have 4.6 in front of you. We've talked about telling if ratios are proportional, but we're going to talk about if it's in a table or if it's on a graph, if those ratios are proportional, what that looks like, what that means. So make sure you have your notes in front of you, and let's get started. Okay, so first, we're going to start with our I can statement, and then we're going to recap how to graph on a plane, like an X and a Y, not just a number line. So first, our I can statement is I can determine if tables and graphs are proportional. So I'll give you a second to write that down. Okay, so when you are graphing on an XY plane, one of these guys, our point is labeled XY. So that's called a coordinate pair or a coordinate point, something like that. Okay, so when you're graphing it, the X value goes first, and it's the horizontal axis. Which is the side-to-side guy. So side to side is X. So you're going to do your side-to-side value first. And then Y goes second and is on the vertical axis. Pen is not happy. Which is your up and down value. Right? So we're going to practice graphing real quick because that's part of this. It's not the main idea, but it's part of it. We need to refresh. So we're going to graph these points. Remember that it's X, then Y. Okay. So for the point 1, 5, my X value is 1. So I'm going to start at the origin, and then go right 1. Then my Y value is 5. So from there, I'm going to go to positive 5. And that's where my point goes. Right there. So that is the point 1, 5. We're going to label it. Maybe we'll label it. There we go. Okay. So for the point 0, 0, we'll come back to that one actually. Let's do negative 3, 4. So from my origin, I go horizontally, my X value, see I was labeled X, I go to negative 3. Then for my Y value, that's the vertical axis, I go up to positive 4, and that is where my point goes. So it goes right here. That's negative 3, 4. Okay. All right, a couple more. We have negative 5, negative 1. Okay, so I'm going to start at my origin. My X value is negative 5, so I'm going to go left to negative 5. My Y value is negative 1, so I'm going to go down to negative 1. So that point right there, negative 5, negative 1. All right, And then our point 0, 0 is the origin. It's right here where we start. It doesn't go up or down. It's just right there. Okay? Alright, so we're going to graph this guy next. So when it's in a table, the pairs of points are this way, right? Here's the x values, here's the y values. So you have 1x, 1y, 1x, 1y. Okay, our x value goes first. So 0, 0. It's just at the origin. I'll switch colors to make it a little easier to see. Okay. Then for this point, 3, 3, my x value is 3. My y value is 3. Next point, negative 2, 0. I start at the origin. I go to negative 2. And then 0 means that I don't move up or down, so it just goes right there on the x-axis. Okay. Last point, 4, negative 4. I start at the origin. I go over to 4. Then I go down to negative 4. So your x value goes first, and his direction is side to side. Y value is second, and that one is up and down. Okay, let's talk about proportionality. Okay, so let's talk about tables. To tell if a table is proportional, the ratio, and real quick, I want you to cross this off where it says x to y. We're going to make it y to x, and I'll show you why in a second. So the ratio of y to x will be equivalent for every point in the table. Okay? So we're going to take that x and y value, write them as reduced fractions, and then if you get the same thing, that means they're equivalent for every time, right? So, right, for ratio, let's say we're going to do y over x. I want you to write that down. Y over x. Okay? So for this point 2, 2, I'm going to take my y value over my x value and reduce it. So 2 over 2. Okay? So when I reduce that, I can divide them both by 2. You get 1 over 1. Okay, we'll move him over here. Let's try writing that again. Goodness. So y over x, we want that ratio, we want it reduced. So my y value is 2 over my x value of 2. To reduce those, I can divide them both by 2. Get 1 over 1. So the reduced ratio for that point is 1 over 1. All right, we got to do it for all the other points as well. We'll scooch him over now. That should work. So now I'm going to take my point 4, 4. I'm going to do y over x. My y value is 4. My x value is 4. Going to reduce those. You can divide them both by 4. And you get 1 over 1. All right, we have one more point. My y value is 6. My x value is 6, so 6 over 6. Can divide those both by 6. Get 1 over 1. So, what that means, since all of these are the same, the ratio when it was reduced is same, they're equivalent, that means that this table is proportional. Bam. That's it. Okay, let's do one more table. So again, I'm going to take the ratio of y to x. For my first point, 1 over negative 2. Those don't share anything, so it's just negative 1/2. Okay. For my next point, my x value is 3. My y value is 2. Okay, we get 2/3. Oh, I did. Hang on, sorry. Let me go back. Mix those up. Y over x. Sorry, I was doing x over y. Okay, so my y value is negative 2. My x value was 1. So that ratio is negative 2 over 1. For the next one, my y over x. Y value is 2. X value is 3. So its ratio reduced is 2/3. Last one, y over x. Y value is 4. X value is 4. I can divide those both by 4. Get 1 over 1. Okay? But in order for it to be proportional, every point has to have the same ratio. These are not the same. That means that this table is not proportional. Okay, it's not getting multiplied by the same thing each time. Their ratios are different. Okay, so y over x, that ratio, reduce it. Okay? Alright, so graphs. Graphs are a little easier, not gonna lie. To tell if a graph is proportional, there must be a straight line connecting every point through the origin. Okay? In graphs, it's just a more visual way to see our ratio. So we're going to graph all these points. Okay? So negative 4, negative 2. So we're going to start at the origin, go to negative 4, then we're going to go down to negative 2. Okay? Negative 2, negative 1. I'm going to go over to negative 2, down to negative 1. Okay, positive 2, positive 1. So start at the origin, go over to positive 2, then go up to positive 1. And then 4, 2, go over to positive 4, go up to positive 2. Okay. So I'm going to take a ruler and through the middle of all the points, I'm going to draw a straight line. Let's get rid of the ruler now. Okay. So it does go through the origin. That means it is proportional. Okay. What's happening is that our y, we're going up 1 over 2. So our x value is 2. So for every one we go up, we go over 2. We went up 1 over 2. Up 1 over 2. Up 1 over 2. Okay? which is what's happening with our other ratios. This is just a more visual way to see it, right? They're changing by the same amount. The point goes up 1, over 2 each time. And it goes through the origin. Okay, I'm going to do a couple of the practices with you since there weren't very many on that page. They didn't really fit. Okay, so for tables, the ratio of y over x has to be the same for every single point. Okay, so I'm going to take my y over my x. Y value is 2 over negative 1. For this point, my y value is 0 over 0. For this point, 2 over positive 1. In order for it to be proportional, to be changing by the same thing, those all have to be the exact same number. My y over x fraction has to be the same. Those are not, which means that this is not proportional. Ow. Okay? Alright, for a graph, it has to go through the point 0, 0. It has to go through the origin. So for this guy, right here, I'm going to find the origin. It's right here. There is not a straight line that goes through that. That means that this graph is not proportional. Okay, so that's level 2. So I'll do one from level 3 with you. Okay, so you can graph it and practice that way. I'm going to show you one more time with the fraction table method. So I want my ratio of y over x, that reduced fraction, needs to be the exact same for all of these points. Okay? So, I'm going to take my y value 1 over my x value of 1. That one's already reduced, 1 over 1. Okay, for this point, my y value is 2 over my x value of 2. I need to reduce it. I can divide these both by 2. Get 1 over 1. So far they're the same, but we gotta check our last one. Okay, 3 over 3. My y value is 3. My x value is 3. Get 1 over 1. So, since all of those are the same, 1 over 1, 1 over 1, 1 over 1. Since we got the same thing, that means that this is proportional. So you can check it with a graph, or check it with a table. We'll also practice checking it with a graph. Okay. So I'm going to graph my points, x, y. So starting at the origin, my first point, x is 1, y is 1. So I go to positive 1, my point goes there. Next point, x is 2, so I go to positive 2, y is 2, so I go to positive 2. Last point, x is 3, so from the origin I go over to 3, then y is 3, so I go up to 3. Then I get a ruler. I draw a line going through the middle of those points. Okay, and I can see also this way that it does indeed go through the origin. Double check that it's proportional, okay? So our y value went up 1, x value went over 1. 1 to 1, 1 to 1. So those are kind of related, okay? So if your ratio of y over x has the same value, so you reduce it and they're equivalent, it's proportional. If you graph it and it goes through a straight line through the origin, it's proportional, okay? If not, it's not. All right. Have a good day, guys. See you later.